if you don't, I'm at like $370. I got like. No. This is that. Yeah, the bowling thing. The strawberries. Very good, and you know, it's really, don't want to have that thing. It's fine. More versus.
So my assumption is that you have completed assignments 1, 2, 3, 4, and that you've graded them all. So if that's not true for you, then consider yourself just behind and you'll have to get that done. Do you have any questions on any of those assignments before we press on? All right. So this is a strategy called grouping, and eventually I can use this. I can show you how to use this to do some of the harder problems from the first 2 assignments. I alluded to this in one of my classes. I don't think it was yours. But those guess ones where you have to do the different templates and guess numbers that multiply to make this, you can use this strategy once you're really good at this. And I might go back and show you that if you're interested. But if you're really good at the trial and error method, then I don't know if it's worth the effort. But anyways, today we probably won't talk about that directly. I just wanted to say that if it's something you're interested in, I can show you. It takes a little bit of the guesswork out. There's still a step where you have to guess. Kind of, not even really guess. Anyways, I digress. So what we're going to do today is factor 4-term polynomials that are cubics that look like this. And eventually, probably next week, I'm thinking there will be a step before what I'm going to tell you is the first step. For now, temporarily, the first step will be what I say. But come next week, when I start mixing all the factorings together, I'm going to start sprinkling greatest common factors into the problems. And there will be an additional sort of step. So today's step 1 potentially becomes step 2 next week. But for now, I'm not going to put any global GCFs in here. So we're just going to keep this simple here for the day. Oh, and by the way, your assignment is on Delta Math today. So if you haven't clicked a link, which I think I provided, if I didn't provide it, I'll get that done today as soon as the lecture's over. I'll get the links up on Canvas. Most of you are already in my Delta Math or in Delta Math. You just have to join this year's specific class. So in a while, this shouldn't take too long, 15, 20 minutes. After that, we'll get our Chromebooks out, click a link, and then you should be able to get right into this year's Delta Math class. So that's that. So there you go. I don't think I've ever asked you to do this before. This is a 4-term cubic polynomial. And to factor it, if I just put it up here and said factor it, it would not be something I would expect you to know how to do. The process is something that most normal people probably wouldn't think of on their own. So what we're going to do is we're going to take this 4-term polynomial and we're going to break it down into halves, 2 and 2. And the way to do that is you're going to draw a wall right down the middle. Sorry about that. Don't know why that happened. You're going to draw a wall right down the middle like this. And pay attention to where I draw this wall. Notice that it's after the second term, but before the sign of the third term. So by drawing that wall, what you're doing is you're breaking it up into a binomial and a binomial, a left side and a right side. I'm assuming you don't have questions on that. Now what we're going to do is we're going to treat each half of the problem like its own little GCF problem. And in order to do that, well, we're going to kind of, and I'll erase this in a second, but we're going to kind of ignore this for the first half. So don't look at that. And I wouldn't scribble it out if I were you, because like you're going to need it. I just wanted to make a point that that's not where our concern lies yet. So what we're going to do is we're going to look at these 2 terms on the left. And we're going to ask ourselves, what's the greatest amount we could pull out of both of those? In other words, what could they both be divided by? What could you get out of both of them? I could get the number 1, which I'm not going to ever do, but you're right. Sometimes, actually, I was a lie. If I need it, I'll get it out of the second half. But in this half, the left half, what's something you could say is in both of those terms? What do they both have? They both have an X. They both have more than one X, actually. Yeah, you would agree that the first term has XXX and the second term has XX. Therefore, in common, we say we can pull out two of them, also known as X squared. Now, when you pull out a common factor, you use parentheses to show what's left. It's the distributive property in reverse. That's all common factoring has ever been, is just anti-distribution, right? It's just backwards. So if I pulled X squared out of the first term, what would be left of him? Good. So the first term, all that's left is X. The minus does not change because I did not pull out a negative. And yes, there's a 4 left from the second term because I pulled out his X squared, but I didn't touch the 4. You're going to be doing that a lot. Any questions on that process? That was just called GCF. Now, when we get to the second half after the purple wall, it's time now to take the sign down. So I'm going to take this plus sign, and whatever it is, half the time it'll be a minus, half the time it'll be a plus. Whatever that sign is, copy it down. And now we focus on the right side. The left side is done. And now we look at the right. What could I get out of 3x and 12? 3, right? They don't have any x's in common, but they do have the number 3, right? We know that both of those numbers can be divided by 3. So I'm going to pull a 3. And what am I going to leave behind? X minus 4. If a polynomial is meant to be or able to be factored by grouping, then you'll always notice something here. Don't force the issue. Don't make it happen. Don't fudge it. Don't cheat it. But you, of course, even early on this Monday morning, would notice that this is the same as this. That's a big deal. What it means is now that what I have underlined in red is a common factor. So I'm going to try to explain something to you. If there's any part of this lesson that's going to go poorly for us, it's going to be the next like 2 minutes, okay? So just watch out. I'm going to take this and I'm going to show it to you in a different light. Imagine if I gave you A times B plus C times B. Like I said, this part is where you could get lost. And I'm just trying to show you why it works. If this part doesn't go well, I can try again. Otherwise, we can just move past it and we can do the robotic process until you're ready to go, oh, I get it. If I gave you the green expression over there off to the right, forget everything that's over here on the left. Here. There, I'll make you forget it like that. It's gone. If I gave you the green expression only, what would you say they both have in common? They have a B. And so I can think of this now as sort of its own GCF problem. And if I pulled that B out front, what would be left? A plus C, right? You agree? Having said that, I'm going to scroll the screen back over now, and I want you to see that what I just wrote over here off to the right, the situation matches the situation on the left. And I'll color code it for you. Like you see these things I underlined in red, how they were the same? Well, that's the same as these. You see how they're the same, right? So what I'm trying to tell you is that in the white and yellow expression over here, do you see how there's a common factor in both of the terms? Right. So what I'm going to do is I'm going to pull that out. I'm going to pull it out. I'm going to GCF it out of there and out of there, leaving me with X minus 4 times something. Now, what's left over of this purple term? If I pull out his X minus 4, X squared is left. And what's left of this green term if I pull out his X minus 4? And that is how you factor by grouping. That will not always be the end of the problem, as you'll see starting in example 5, I think is when it starts changing. But we're going to practice that. That's just a process. Draw the wall, GCF, GCF, finish it off. Okay. Any questions on that? Okay. Let's do another one. Today's problems will all sort of look the same. You'll recognize them as cubic 4-term polynomials. What's step 1? Draw the wall, right? So use a color, don't use a color, but I'm gonna try to keep it consistent, the purple wall. And that breaks the problem up into left side, right side. What is the GCF of the left side? X squared. What does that leave behind? Nice. Good job. What's the next step? I'm sorry, I can't hear you. Mhm.
Like you drop that line.
Now, that was what I was hoping to hear. This step often gets overlooked like it's sort of like a little optional step. It's huge. The next thing you have to do is take the sign right after the purple wall. If it's a plus, copy it. If it's a minus, copy it down. And that's massive because that means that when we do the second half, we're not pulling out a number, we're pulling out a negative number. It's a big deal. When you pull out negatives, things get a little wonky, right? So we survived that. Now what can I get out of 2x and 6? So I'm going to pull out the 2. And what does that leave behind? No, it does leave an x. There it is. Now, you're like, what is this black magic, Steve? Why are you changing the signs here, like making up your own thing? And the reason is because we respect the fact that when we pull a negative out of something, in the same way that if we multiplied a negative into something and the signs change, we have to change them when we pull it back out. So when I pulled out this yellow -2, the -2x changed to, excuse, my arrow is pointing in the wrong direction. My -2x changed to a +x, and my -6 changed to a +3. Everyone has to take that, have that effect applied to them, the negative effect. And again, do not force the issue. Do not fudge it. Don't get all cute because you want those white parentheses to match. Okay, don't cheat it to make it happen. Let it happen. And if it doesn't happen, then go back and identify why it's not. Something has gone wrong, and it could have happened before that. So again, don't force the issue. But what you should see if things are going well is that this and this are the same. That makes that now the greatest common factor. And I can pull it out to the left. So my first factor for my answer is x plus 3. That is called a factor. What's my second factor? And you'll notice that x squared minus 2 is suspiciously close to being a difference of 2 squares. That was one of the things I wanted to try to get stuck in your head via the first 2 assignments of the year, but it's not quite a difference of squares because 2 is not agreeable to that. 2 says I'm not square. I'm not a square, like I'm not square rootable, but it's close. Hint, hint, wink, wink. Like that's what's coming down the pike. So for this one, it's done. Sometimes you can go further, sometimes you can't. Example 3. Starting next week is when the factoring unit gets more difficult. I think the first 2 weeks of factoring are easier because I teach you a skill and we practice that skill. Like when we did cubes, that's all we did. When we did quadratics, that's all we did. Starting next week is when they all come together in a big brutal worksheet where you're like, oh my God, now I have to recognize, are they squares? Are they cubes? Is it a normal trinomial? Is it a square trinomial? Is it grouping? All those factors come and sort of gel together. So when the time comes and I'm sitting here looking at a big quiz or a worksheet, how will I know to do this by grouping? What's the grouping telltale sign? There's 4. that becomes pretty much our sign to say, this is one of those draw the wall problems because there's 4 terms. Good job. So to begin, I'm going to draw the wall. What is the GCF of the left side? 3x squared. I can get a 3 out of the 3 and the 6, and I can get 2 x's out of both terms. Get as much as you can. We don't call it a CF, right? We call it a GCF. The G is for greatest. It's important. What's left of the left half if I pull out 3x squared? X minus 2. And there's no x's left in that second because I pulled out all of the x's from that. If you're ever not sure if you pulled correctly, you can always redistribute. It takes about 3 seconds to do mentally. If Jordan was sitting here like, I don't know, she could just multiply it back in and verify that it equals what she started with. Okay, yeah. Next step. Drop down the plus. Very good. And that means there's a little less stress in this problem because we're factoring out a positive. We don't have to worry about sign changing. What can you pull out of 4x and 8? 4. So I'm going to pull a 4. And that leaves behind. And again, that means the theme, I'm not going to trick you yet. Okay. Today's theme is let's practice a skill. And the skill should lead to this and this being the same. Just let it happen. What's my first term, or but the first factor in my answer going to be? Yeah. And the second one? Does anyone right now feel like it's a good time to ask a question? We've done 3 examples that ought to be probably clicking at this point. Okay. And again, I want to look at it and see if there's any more meat on the bone. And no. 3x squared plus 4 never had a chance. It's garbage. It's got a plus in it. The 3, it's terrible. So it's done. Right, I have one more sort of warm-uppy, and then we're going to get to the multi-step ones, and then it's time to work. I don't really know how or why. Oh, I do know why. I remember now. Okay, this is where I think things are going to change. 4th example, not the 5th. Just looks like another grouping problem, right? We just go into it, business as usual, but you're going to see something at the end. So I'm going to draw the wall right there. What's the GCF of the first half? And what will that leave behind? Nice job. X plus 10, because I only pulled out x squared. The 10 doesn't shrink because I didn't pull out any numbers, just x's. Next step. Bring down that minus sign. So the minus just takes a drop. And that's where we kind of step up our game a little bit and just, it's not hard. We just got to be a little bit more careful because we know there's some sign switchage to come here. Now, this comes back to something that Kaysen said about 10 minutes ago. And I told you, like, most often we don't pull ones out on purpose. Like they're wastes. But in this case, it contains much importance. So I'll ask you, what can you get out of x and 10? 1. And normally, again, pulling a 1 out is a waste of time. It's a literal waste of time to pull out a 1 because you could pull out a 1 and then pull out another 1 and you could keep like a madman. You could keep pulling out 1s. But in this case, I need something after the minus sign, even if it's a 1. And so when I pull, I am not going to say I can't pull anything out, like I can't get anything. I am going to pull that 1 because I need something there structurally to build that other factor. Even if it's just a stupid little 1. What's left if I pull out a negative 1? X, change the sign, 10. Nice. What will my first factor be? What will my second factor be? X squared. Good. And this is where, for the first time, we realize now that we are not done. What, oh, what is that? Get used to this because this guy, It's a difference of two squares. If you fail, now you're going to get lots of days to practice this. But if, say, a week from today, you're unable to see that that's what that is, you're in for it. It's going to be a real rough first chapter for you. That guy, I know from the first couple of assignments, is a difference of two squares. That's a minus sign in the middle, and x squared and 1 are both squares. Therefore, by definition, that purple thing needs to be factored more. And when we factor, we don't factor a little. The directions will always say factor completely. And in the last three examples, I've been able just to stop. But there's more meat on this bone. What does x squared minus 1 break into? X plus 1x minus 1. Now that is done. You have to be vigilant on the watch for those differences of squares. Later on, probably not soon, but within the next week and a half or so, you're going to actually see sums and differences of cubes appearing at weird places and problems. It's like, whoa, those are cubes. But for now, all we're going to see, the guys that creep in and make us do more work, are going to be difference of squares. That's a final answer. Let us go again. Step 1, draw the wall. Step 2, GCF. Nice job. So we're going to pull 4 and also x squared out of the first two terms because we can. What's that leave behind? Next step, bring down your minus. Now, what can I pull out of 9x and 36? 9. You can get out a 9. 36 and 9 are both divisible by 9, so I'm going to pull out a 9. What's left over if I pull out a negative 9? X, change the sign, 4. Got to change the sign when you divide by a negative. What's my first factor? And my second factor? Good. And I'm here to help you for now, but there comes a day where I'm not there. It's quiz day, and I'm not there to show you what that is. What is that? It's another difference of two squares. He just showed up, he just crashed our party. And I recognize that this is a difference of squares because the square root of 4x squared is 2x, and the square root of 9 is 3, and that, last I checked, is a minus sign. It does not work with plus. If it was 4x squared plus 9, game over. Squares can only be factored if there's a minus in the middle, or the magic doesn't work. So my final answer consists of the one we had before, and then what are my other two factors?
2x plus 3. 2x 5 is 3.
None. You feeling magical? Hugo, you got this? Got 2 more for you. Okay, just want to make sure. Getting the flow. Soon. Step 1. Draw the wall. What is the GCF of the left? 9x squared. Nice job over there. If you said 3x squared, you're going to struggle. Like you're going to miss this. Or if on the second half with the 8 and the 12, if you say 2, this is going to be harder for you. Remember to stress the G in GCF. Okay, we don't want just any old CF. We want the G, the greatest. What's left of the left half if I pull out the 9 and the x squared?
2.
I need a 2x plus 3. Nice. And again, if I'm not sure, if that just didn't feel right, then I can always multiply it back out. You don't have to do this. I'm just going to show you. You could always multiply these back out and make sure that they equal this if you want to. Next step, drop the minus. What is the greatest common of 8 and 12? 4. So I'm going to pull out a 4. And what does that leave behind? Plus 3. And you'll notice throughout the year, I've been doing this for years, that when I do notes, I use colors. And I just wanted to say that you guys, when you take notes, you're welcome. Not like I'm not the boss of your notes, but using colors is a good idea. And the day before a quiz, when you are preparing the page of notes that I let you use, that's another good time to use colors. When you're creating that masterpiece page of notes, then maybe that's when you start busting out the highlighters and the funny colored pens and really try to, like I do, be consistent with what colors go certain places, if it helps. So what are my 2 factors? Notice anything? It's another difference of squares. That is a difference of 2 squares. I'm going to try to keep hitting you with that. What is the, what are the 2 here? Let me copy down the first one. What are the 2 factors that our difference of squares is going to break into? 3x plus 2 and uno más. Easy peasy. Nothing to it. Okay. Last one. And then we will get on delta and get that going, rocking and rolling. Step 1. Draw the wall. The wall is like optional, obviously. I just think it's a good visual aid. Gives us a good like concrete starting point. What's the GCF of the left half? 4x squared. You have to pull as much as you can. What is left over? 3x minus 4. Very good. Next step. Drop the minus. What can you get out of 3x and 4? Nothing, aka 1. Good. Thank you for saying that, Steve. 1. When it looks like there's nothing, take the 1. What's left over if I pull out that negative 1? 3x, change the sign, 4. And for the 4th straight problem, you see it coming down the pike. And when you start getting really good at this, you see the difference of squares. It's in yellow on the TV. You see it already. You know he's there. But I'm not going to skip it right now. I'm going to bring down my 3x minus 4 because he's the same as he's 1. You bring out a copy of that to the left, and then you have 4x squared minus 1. I wanted to really inject a lot of those into today's lesson to try to drive the point home that be vigilant, be watchful. 1 step sometimes isn't enough. Throughout today's assignment, you might find 75% of the problems, 1 step is enough. But because it's Delta Math, it's random, Hugo might get 50% of his that have difference of squares, and Shanessa might get 15%. That's the nature of the randomness of Delta Math. So the difference of squares ought to stick out like a sore thumb. You see it, and now it's time to finish the job. So we have 3x minus 4 times what?
2x. Yeah, 2x plus 1.
Gorgeous. And that, my friends, is that. So I'm gonna probably stop the recording. I don't think you're gonna have any questions. Give me just a quick moment. I'm gonna head to today's Canvas because I don't think I ever posted Delta Math links. Let me get those up and you can clicky and join in. Let's make sure we get in. Yes, Steve. I'll go ahead and pause. Guys, don't forget Shift 6 on Delta Math will make your cursor go up. So what is your original question? Yeah, like on your screen. Yep. Okay, plus 80, okay. Here's a question real quick with some much larger numbers. So let's take, if you want to come along for the ride, you're welcome to. Yeah, listen, I'm going to say this and I'm going to put this on my recording. I really think you all, Kane might be the only one who doesn't need to listen to this because I just had this conversation with him. If you can get this today, like today, your existence in my class will be better for the next like 2 or 3 weeks. Kennedy is faced with this. One of her factors says this. And doesn't that look like it wants to be factored? It cannot be. You cannot factor squares when there's a plus sign in the middle. This is called the sum of squares. You cannot factor it using real numbers. Therefore, if you are faced with a factor that looks like this, it is done. We could go further if it said x squared minus 9, but a sum of squares is dead. So you should have stopped right there. Got it? Sums of squares cannot be factored using real numbers. Back to your question. So step 1, I'm going to draw the wall. And what can you get out of the second or the first half? And that leaves behind x minus 5. Next step. Right. Shift 6. Now this is tough because those numbers are really big. So there's a hint in the problem, like the fact that we're trying to get it down that far. And I don't actually, oh, I should have had 4x minus 5, Alicia. I'm so sorry. I'm not going to count that as an incident because I caught it. So there you go. Right. We agree with that, right? 4x minus 5. Now, the fact that we're trying to get it to look a certain way that we could actually take the hint in this case. What do you think that 64 and 80 can both be divided by? True. We can go bigger. They can both be divided by 8. Go bigger. Would you believe me if I told you that both of these terms can be divided by 16? Yep, it's true. And so if you take the 64 and the 80 and you realize, hey, they can both be divided by 16. What is 64x divided by 16?
You got 5 minutes.
Okay. And then we have to change the sign from plus to minus because we pulled down that minus. So we're factoring out a negative. So we change the sign to minus. And what's 80 divided by 16? Yep. So what are our two factors? And? I already did the 4x minus 5. That's the one that they both have. So I pulled that out in front. That's the common one. I've been color coding this for your convenience. Do you see the two things that I've written in yellow? That's what forms the second factor. The things that you GCF'd out of the left and out of the right, the yellow things and all my problems, those are what compose or build the second factor. So the x squared comes in and the minus 16 comes in. Now, if you have a decision to make at this point, you either stop.
The interruption. Students, please take out your Chromebooks, pop them open, open your RTI.
So your choice here is, do I stop and type this in or do I go further?
Oh.
Which one do you think can be factored more? I agree. What is it? I like that you took your time and said that the right way. Good job. And honestly, your ability to see those and know what to do with them will separate, like, it'll be like a 20 or 30% difference in your first test grade. So good job. Recognize him. You're like, I know who you are. You're one of those difference of two squares guys. So we're going to leave the 4x minus 5 alone. And what does x squared minus 16 break down into? Not 4x, no. What? There you go. There we go. We need one of each, x minus 4 and x plus 4. And now you can say, I'm done. There's no more meat on the bone. Got it?
Oh, yeah, no, I'm asking. Oh, gotcha. Oh, you don't have to do anything with the bus. Yes, I know. Oh, how do I put that in the process?
So what's your original problem? Hey, I'm still doing a math problem with someone, so just because you're done and packing up doesn't mean that I'm done, so please stay quiet. What's up?
3x cubed plus 2x squared plus 48x plus 32.
Plus what?
32.
Okay, so we're gonna draw the wall. What is the GCF of the left side? Oh yeah, a lot.
Oh, x squared.
Yep. And that's gonna leave that. And then we're gonna pull down our plus. Now, what can you divide 48 and 32 both by?
I messed up. 6, right? Or 8. 12.
Mm-mm.
How is it?
Keep going.
We please get Jack Kushner to the office.
You can do 8, but it's not the most. What's the most you can divide them both by?
Oh, so the whole.
Nope.
This
They can both be divided by 16. So we're gonna pull out a 16, and that leaves behind 3x and 2. So what are our factors?
Oh, 3x plus 2.
And
Oh. X squared. Plus 16.
do we go further or do we stop?
Go further.
You can't go further, Kane,
Oh, you
because that's a plus sign, right? Okay, so done. Okay,